Welcome to our exploration of the incredible world of volcanoes. These powerful geological features have long captivated our imagination, playing a significant role in shaping the Earth's surface and influencing the environment in various ways. In this segment, we'll provide you with a brief overview of what volcanoes are, how they form, and the role they play in shaping our planet. Volcanoes are openings or vents in the Earth's crust through which molten rock, ash, and gases escape from deep within the planet. They form when magma rises to the surface due to the movement of tectonic plates, pressure from the underlying mantle, or the presence of a hotspot. As the magma reaches the surface, it can create new landforms, build towering mountains, and even alter the course of rivers. Volcanic activity has played a crucial role in shaping the Earth's surface for millions of years. Volcanoes have created vast mountain ranges, fertile soils for agriculture, and unique habitats for a diverse range of species. Furthermore, volcanic eruptions release gases like water vapor, carbon dioxide, and sulfur dioxide into the atmosphere, which can have both short-term and long-term effects on the Earth's climate. So, let's embark on our journey into the fascinating world of volcanoes and discover the powerful forces at work beneath our feet. Stay tuned as we dive deeper into the different types of volcanoes, the various eruption styles, and the hazards they pose to human society. Now, let's explore the various types of volcanoes and their unique characteristics. A. Shield volcanoes are characterized by their broad, gently sloping shape, resembling a warrior's shield. They form from eruptions of highly fluid, low-viscosity lava that spreads out over a wide area. Some well-known examples of shield volcanoes include Mauna Loa and Kilauea in Hawaii. B. Stratovolcanoes, also known as composite volcanoes, are characterized by their steep, conical shape. They form from alternating layers of lava flows, ash, and other volcanic debris. Stratovolcanoes can produce explosive eruptions and are often responsible for some of the most destructive volcanic events in history. Examples of stratovolcanoes include Mount St. Helens in the United States and Mount Fuji in Japan. C. Cinder cones are the simplest type of volcano, characterized by their small size and steep, conical shape. They form from eruptions of gas-rich, relatively viscous lava that cools rapidly, creating a mound of cinder-like volcanic rock fragments. Some notable examples of cinder cones are Pyroclastic in Mexico and Sunset Crater in Arizona. D. Calderas are large, bowl-shaped depressions formed by the collapse of a volcanic summit following a major eruption or the emptying of a magma chamber. These geological features can be enormous, sometimes covering several kilometers in diameter. Two famous examples of calderas are Yellowstone Caldera in the United States and Crater Lake in Oregon. In the next segment, we will dive deeper into the various eruption styles and the hazards associated with each type of volcano. Moving on, let's discuss the different types of volcanic eruptions and the factors that influence them. A. Effusive eruptions are characterized by the relatively gentle outpouring of lava onto the Earth's surface. These eruptions usually produce large volumes of fluid, low-viscosity lava that can travel long distances, creating extensive lava flows. Effusive eruptions are commonly associated with shield volcanoes, such as those found in Hawaii. B. Explosive eruptions, on the other hand, are characterized by violent explosions that release large amounts of gas, ash, and volcanic rock fragments into the atmosphere. These eruptions can generate dangerous pyroclastic flows, which are fast-moving clouds of hot gas and debris that race down the volcano's slopes. Explosive eruptions are typically associated with stratovolcanoes, like Mount St. Helens and Mount Vesuvius. C. Several factors influence the type of eruption a volcano produces. One major factor is the composition of the magma. Magma with high silica content is more viscous, which can trap gases and lead to explosive eruptions. In contrast, magma with low silica content is less viscous, allowing gas to escape more easily and resulting in effusive eruptions. Another factor is the gas content within the magma. Higher gas content can increase the likelihood of an explosive eruption, as the gases expand and create pressure within the magma chamber. In the next segment, we will explore the various hazards associated with volcanic eruptions and how they can impact the surrounding environment and human populations. Now let's explore the various hazards associated with volcanic eruptions and their potential impacts. A. Lava flows are streams of molten rock that pour out of a volcano during an eruption. While they may appear slow-moving, lava flows can travel at considerable speeds and can be extremely hot, reaching temperatures of up to 1,200 degrees Celsius, 2,200 degrees Fahrenheit. They can incinerate or bury everything in their path, destroying vegetation, infrastructure, and even entire communities. Devastating lava flows include those from Kilauea in Hawaii and the 2018 eruption of Fuego in Guatemala. B. Pyroclastic flows are fast-moving avalanches of hot gas, ash, and volcanic rock fragments that race down the slopes of a volcano during an explosive eruption. These flows can reach speeds of over 700 km per hour, 435 miles per hour, and temperatures of up to 1,000 degrees Celsius, 1,832 degrees Fahrenheit. They can be extremely deadly, as demonstrated by the destruction of Pompeii in 79 AD and the 1997 eruption of the Soufriere Hills volcano in Montserrat. C. Lahars are volcanic mud flows or debris flows that can occur when volcanic ash mixes with water from rain or melting snow and ice. These flows can be incredibly fast and destructive, burying or sweeping away everything in their path. The 1985 eruption of Nevado del Ruiz in Colombia produced a deadly lahar that killed more than 23,000 people in the town of Armero. D. Ashfall and volcanic gases pose additional hazards during a volcanic eruption. Volcanic ash can blanket the landscape, causing respiratory issues, contaminating water supplies, and damaging buildings, crops, and infrastructure. Volcanic gases, such as sulfur dioxide and carbon dioxide, can also pose health risks and contribute to the formation of acid rain. Ash clouds from volcanic eruptions can be particularly dangerous for aviation, as the ash can clog jet engines, leading to engine failure. The 2010 eruption of Eyjafjallajökull in Iceland, for example, caused widespread disruption to air travel across Europe. In the next segment, we will discuss how these hazards can be mitigated and the importance of volcano monitoring and preparedness. In this section, let's discuss the methods used for monitoring and predicting volcanic activity, which are essential for mitigating potential hazards and ensuring public safety. A. Seismic activity is one of the primary indicators of volcanic activity. Earthquake swarms, or a series of small earthquakes in a short period, often precede an eruption. Scientists monitor these seismic events using seismometers, which detect and measure ground vibrations. By analyzing seismic activity patterns, researchers can gain valuable insights into the movement of magma beneath a volcano and assess the likelihood of an eruption. B. Ground deformation can also signal an impending volcanic eruption. Uplift, or the rising of the ground, and subsidence, or the sinking of the ground, are both indicators of changes in magma movement and pressure within a volcano. Scientists use GPS and satellite-based monitoring techniques, such as interferometric synthetic aperture radar, INSAR, to measure ground deformation and track potential volcanic activity. C. Gas emissions from a volcano can provide crucial information about the state of the magma and the likelihood of an eruption. Changes in the composition of volcanic gases, such as an increase in sulfur dioxide, can indicate that magma is rising towards the surface. Scientists use various monitoring tools and techniques, including gas chromatography, spectrometry, and remote sensing, to analyze gas emissions and better understand the processes occurring within a volcano. In the next segment, we will explore how communities can prepare for volcanic hazards and the importance of effective communication between scientists, emergency managers, and the public. As we conclude our discussion on volcanoes, let's highlight the importance of understanding these powerful geological phenomena and their associated hazards. Recognizing the potential dangers posed by volcanic eruptions is crucial for the safety and well-being of communities living near active volcanoes. Science plays a vital role in predicting and mitigating volcanic risks. Through the monitoring and analysis of seismic activity, ground deformation, and gas emissions, scientists can provide valuable information about the likelihood and potential impacts of an eruption. This knowledge allows emergency managers to make informed decisions about evacuations and other safety measures, ultimately saving lives and minimizing the effects of volcanic hazards on human society and the environment.